Good Thursday to you, everybody, in Gov 603. Welcome to week kaboom! 8. Yeah, 8. That many. How are you doing? Hey, hang on. Let's just get things in the proper order here. Much better. What we have, the Great Smoky Mountains Cup. Hope maybe to get there, spring break. We'll see. Okay. Welcome to week 8. How's everybody doing? You doing okay? This video is going up a little bit later because I wanted to make sure that you were focused on the exam, which closed yesterday. Okay. And I believe everybody got into the exam. Let's just take a really quick look as long as we're all here together. Midterm, let's see. Okay, looks like everybody is here that was planning to be here. All right, sorry for that delay. Okay, there are obviously some questions in the midterm that I have to grade, like your short answer and stuff, and I'll be doing that over the next couple of days into spring break. As with part 1 of your papers, if you get a little note from me that we need to chat, make sure that you reach out. And typically, what I'll do, if there's something I got to talk to you about, is I will put a 0 as a placeholder for the test, because the way that Canvas works, excuse me, I have an itch in my back here. The way that Canvas works is I have to put something in there in order to send you a note. Dumb, I know. So if you see a 0, don't panic. Okay, that's because I needed to get with you here for whatever the reason, and then we'll take it from there. Okay, so test done. All right, I'll talk about the results on the other side of spring break. That is modular week, which is this coming week, week 9. So there are no readings, there are no questions, there's nothing to. You get to take a break. Okay. Keep working on your papers. All right. And I think I heard back from everybody that I gave a note to and said, hey, let's talk. I'll double check, but you double check too. Okay, let's take a look at the material for this week. Where you're going to get to know a particular type of test that's very, very common in empirical research, especially in quantitative research. Okay, and it's 2 variations of the same type of test. The first one is called a t-test, and then the second one is abbreviated as an ANOVA. That is ANOVA. All right, what are these tests, and why should you care? Or that is how are they used? All right, I'm reaching for my magic pad here to show you. In fact, I think I already have some of this. Do I have some of this here? Okay, because I like to keep these illustrations handy for when I need them. And no, I do not. That's all right. We're gonna put them together. Okay, now, as you might be aware at this point in the course, empirical researchers and statisticians are much obsessed with the mean. That is the center part of the curve. Or another way to describe that is that they, not so much technically, but commonly it's referred to as the norm. So that's the average that something happens when done by some bodies. Okay, and that can be everything from voting for a particular political party when they hear certain messages to smoking cigarettes. Does anybody really smoke anymore? I mean, I know some people that use nicotine pouches, and except for in most cases when it's none of my business, I have one of my sons does that. From time to time, I'll remind him that nicotine is not good for the cardiovascular system. So although it's not smoking, which is good, not good for the cardiovascular system, not so good. Okay, so let's and it's also sort of jack you up. Let's use that as an example. Nicotine pouches. Okay. So let's say you wanted to find out what effect on the blood pressure nicotine pouches have. Okay. And you set up a little study. Okay. And what you did was you asked people who use nicotine pouches to record how many nicotine pouches, okay, over how much period per day they used. All right. And then you gathered that data and then you put it on a graph where the Y side was the number of nicotine pouches, and then the X side was the times per day. Okay. Or, you could have the number of times per day on the Y side, and on the X side, you could have blood pressure. Okay. Let's do it like that. And then you divided, you got a bunch of people to volunteer, nicotine pouch users, and you divided them up into, let's say, two groups. And, the first group that you were going to look at, you just split them by gender, male and female. Okay. And let's say we're going to focus on blood pressure here in this example. Okay. Okay. So you took a group of women and who use nicotine pouches, and you took a group of men, and you want to make sure, again, as we've learned in terms of random sampling, that there's roughly parity between the two groups. They're in the same age. They weigh about the same in terms of body mass for men and women. They have about the same level of physical activity. Okay. They have, relatively speaking, the same diet. So you don't get any weird skewed effects on blood pressure, because there are other things that can affect blood pressure. Diet, exercise, sleep, all of this stuff. Okay. And you do this over the course of a month, and you record your data. Okay. And then, so for the men, and this is all hypothetical. Okay. You get something that looks like this. We're going to focus on blood pressure. Okay. So the blood pressure, this would be the blood pressure rate going right here. And then this up here on the Y axis is the number of nicotine pouches that they use during a weekly basis. Okay. So you track their blood pressure. Now, some of the guys, okay, where the number of nicotine pouches are low, their blood pressure will be, say, normal. And then as the number of nicotine pouches that they use goes up, their blood pressure goes up. And there are going to be some in the group, okay, way over here, that even just a small amount of nicotine pouches is going to cause their blood pressure to be really high. But what you're interested in is the average. Okay, this top of the curve. And then you do the same thing for women. You track the number of nicotine pouches they use. Let's say it's per week. You measure their blood pressure. Some are going to have this low effect. Some who use just very few nicotine pouches will have a really high blood pressure, because the further out you go this way, the higher the blood pressure is. But you're interested in what's right in the middle, the average. Now, let's say you wanted to ask and find out, is there any difference in the average change to the blood pressure between men and women using the same amount of nicotine pouches over the same amount of time. The way you would do that is with a t-test. What a t-test does, it compares the average outcome of, and you can work it either of two ways, of two different groups of people doing the same thing, okay, or the same group of people doing two different things. So in this case, it could be you just took both men and women and you looked at those that used nicotine pouches during the week and those who didn't use nicotine pouches during a week, and you compared the average of their blood pressure. A t-test will tell you if there's any statistically significant difference between those averages, which would tell you that there is a significant difference in the effect, in the impact, in the cause of the thing that you're studying. And in this case, it's nicotine pouches. Okay? That's a t-test. It's very simple. Now, there's some math that goes on behind the scenes. And when we come back from break, I'm going to give you some data that you're going to be able to put into a little online calculator that runs a t-test. So for this class, I don't require that you memorize the formulas that are used to produce a t-test. It's really not that complicated by way of mathematics, but that's not the focus here. We're looking at empirical research, what it is and how it's done. Okay. So if you're reading a study and you see the word t-test, that's a dead giveaway to you that what's going on is that the researcher is comparing the averages. Okay. Remember, like the two graphs here, the average for men, I should have an M there for male, and the average for female, comparing the average of either two different groups doing the same thing or the same group doing two different things. So two different groups, male, female, same thing, nicotine pouches. One group, male and female, doing two different things, nicotine pouches, no nicotine pouches. That's a t-test. That's it. And the usefulness of it is the reason that it's not that empirical research is obsessed with the average. I mean, like, oh, who's just average? You can't think of it that way. Okay? Because when you graph data, when you get here and over here, okay, you're getting the extreme reactions of things, either no reaction or a lot of reaction. Right? Well, what you're after is what's the central reaction? What's the main reaction to that thing? And again, this could be everything from how do people behave when they hear a certain message or when a candidate does a certain thing, say on the political science side, to how does the body respond when there's a certain stimuli like nicotine pouches. And what researchers are interested in is this central band, starting from right in the middle of the curve and then going out on each side, depending on how quickly the curve drops off. Okay. They're interested in the outcome for that group of people because, number one, numerically, this is the greatest number of people in a study. So if you have 1,000, okay, this comprises somewhere around 70 to 80%, depending on how steep the curve is or how flat it is, okay, of the people participating in the study. And then these guys out here will comprise about like 10%. This space. Okay, so and I'll just use a pencil here. If we just color it like this. So the people who would fall into the sections of the curve that were outside of this normal band. See that? Okay. That's the minority of the folks in the study, in the test that you're looking at. The minority in the behavior. And then that's not to say that, what happens in a small percentage of people is not important. In fact, And sometimes it can be very important. Sometimes what you want to look at is what's happening way out here on the end of the graph. This is particularly true in politics. It's rare, extremely rare, that a majority drives a revolution. And I don't mean, like off with their heads or something, but some sort of major political change. Okay. The minority tends to drive that. And, you can look at the history of revolutions, say in the Western world, say, you can look at the French Revolution, that swept across, because it started in France and then actually sweeps across Europe. You can look at the communist revolution in Russia in 1917. You look at the fascist revolution back in Europe again in the 1920s and 30s. And what you find is that the core of these political parties is a small percentage. I mean, sometimes, significantly less than 10%, sometimes even, around 5, 6 or 7%. A very small group of people start a social movement, and all the folks in the middle tend to either just go along or do nothing by way of opposition. They may not be really keen on, say, fascism, which was widespread across Europe in the early 1900s. It wasn't just a German thing. It was in France, it was in Spain, it was in Italy. In fact, it started in Italy. It was in, the Eastern European countries. It was in the Scandinavian countries. Okay. The people that drove that revolution, that actually put together the political parties, very small. And there were people that weren't keen on this ultra nationalistic fascist revolution, but they don't do anything. People tend, when you look at human behavior, those that fall in the middle tend not to do anything. That's just human nature. In fact, there's some fascinating, Google this up if you get some time, studies on whether or not, if you are in distress, whether or not you're likely to get more help or less help, depending on the size of the crowd that's around you. And the data points to the larger the crowd, say if you're in a large crowded city, the less help that you get. And there are a bunch of reasons that, some they speculate and some they can put their finger on for this. But the point still made that when you talk about human behavior, majorities do not make revolutions. So there are times in which, as a researcher, you're really interested in what's going on way out on the edge, right? Other times, let's say in the case of blood pressure and nicotine pouches, you're not. You're interested right in the middle. A t-test will tell you, if comparing the two averages, you take sort of the two bell curve graphs and you put them over on top of each other, if there's any meaningful difference, or if it's just random, just because of the people that were in the various groups. All right. That's a t-test. An ANOVA is essentially a t-test, but just to the next level, because an ANOVA does one step more than tell you if there's a statistically significant difference. An ANOVA will start to tell you how much of the difference, say between blood pressure and nicotine pouches, is what percentage is being caused by the thing. And ANOVA stands for analysis of variance. Variance of what? The variance between this average and that average, the variation, and the variance between the cause and effect. So using an ANOVA, and an ANOVA is part of a group of studies like t-tests that are called regression studies. Regression tests are sometimes referred to as linear regressions, because you're interested in what's happening along a straight line in a causal manner. What's causing this to go the direction that it goes? Okay, that linear regression and ANOVA will give you a number. Now, this is not an exact science. Okay, this is like the weather. It's a percentage. It's like, well, to the best of our ability to crunch the data, 70% of what's happening over here is being caused by this. And when we get back from the break, I'm going to give you some numbers concerning COVID and what happened to some people who got COVID that'll let you take a look at the top causal factors for really severe COVID outcomes. All right. And I'll explain that when we get back. All right. So a t-test simply compares the means, the average between two events, either two groups doing the same thing or the same group doing two different things. And an analysis of variance or linear regression takes that one step further and lets you start making predictions about how much of the causer is causing the cause. All right, makes sense? Pretty straightforward, right? No need to be afraid of this stuff. All right, so for this week, I got some videos for you to watch that will explain this to you, and then I've got some questions for you to read. Okay. And I will be grading your midterm exams. And if you get a little note from me that we should talk, please reach out to me. We'll schedule a time. We'll sit down and we'll get you all taken care of. Okay, everybody, have a fantastic rest of the week, a weekend. Enjoy spring break, modular week. Take a break from these classes. Go out into the sunshine. Get some vitamin D and some fresh air. Remember, I think about you. I pray about you. And I'll see you on the other side in week 10. Okay? Take care, everybody. Bye-bye.